We're going to talk about the teleradiology workflow that we go through to exchange information. Just as a global overview, this is the ordering physician. He sees the patient, he's going to order an exam. That's going to go on to the modality. So the CT scan is done. Once the images are there, they're going to get transmitted to the data center for storage. Then from storage, they're going to get over to the workflow coordinator who's going to ultimately send the images to the radiologist. Radiologist is going to interpret the exam and then make a report, send that back to the ordering physician so the ordering physician knows what to treat. This is a hospital overview of how all of this is interacting together. This is the PAC system here. PAC system includes a lot of different parts, but so we're looking at the technologist's work desk, the PACs to look at the images, and the radiologist's workstation to look at the images. Up here is the modalities, so the images are going, or the information is going to the PACs via DICOM connection between the different modalities and the PAC system. Then from the PACs, it's going to communicate with the RIS, which is Radiology Information System, via an HL7 communication. And then from the RIS to the HIS, which is a Hospital Information System, by an additional HL7 connection. Now, that case I just showed you previously, the PACS is located basically at the same location as the hospital or imaging center, whichever you're working with. However, you have to deal with things a little bit differently when the PACS is actually hosted off-site, which is the case with us. So we use a company called Radius. They're based out of Tennessee, and they do all of our IT storage and PACS and RIS for us. So this is, if we did not use anything other than a secure connection, it would go from the modality to the PAC system. And we'd need a VPN connecting each of the different modalities to the PAC system, which we could definitely do. However, it would entail, put in a lot of different a lot of different VPNs together, and somebody's going to monitor those, so that'd be getting very complicated. So what Radius did is they came up with something called an edge gateway, and that's this box here. It's about the size of a modem, and what it does is it has a secure connection from itself to the PAC system off-site, so there's no reason to put a connection there, and then you can just send directly from the modality to the gateway system here without having to put a VPN in. So it makes things a lot easier for the customer. Radius is located in Tennessee. It says Nashville here. They're technically in Hendersonville, Tennessee, which is a suburb of Nashville. This is showing their two data sites where things are stored, which makes things redundant. So if something goes down at the data site in Atlanta, Georgia, the one in Nashville, Tennessee would take over and keep all our information. And this is pretty common. You need to always have your data stored in at least two sites. So what is a PACS? A PACS is a picture archiving and communication system, and it's important to realize it is a system, so it's not just one particular thing. It's a technology that allows for exchange of information between short and long-term storage, retrieval, management, distribution, and presentation of medical images. So it's allowing that healthcare organization to transport their hits, so their health information technology, so their information over the internet, and ultimately store it or get it to the radiologist to be viewed, things like that. So this is breaking it down a little bit more and showing it a little bit more visually, but the different components that make up a PAC system includes the modalities themselves, which you see over here. It's not showing you the x-ray, I think is above here, but it's there. Everything is transmitted by DICOM over to the workstation. From the workstation, it's going to get transported to the archive, and this is also going from the archive to the radiologist's workstation. So again, we got the radiologist over here, the technologist here, images getting taken here, and then all the information is stored right here in our archive. So these are the different components of what a PACS actually is. Now I talked about DICOM, and DICOM is important because it is a protocol that allows for sharing of images and other medical information. It's a standardized format to do things DICOM stands for Digital Imaging and Communication in Medicine. And again, it's going to allow you to communicate uh, between the PACS, the Radiology Information System, other medical imaging systems in a secure manner, in a reproducible manner, probably more importantly. Just gives you the standard for transferring that data. The other thing that you saw in that previous chart was an HL7 connection. So an HL7 is a secure interface that we're going to have that is giving you basically a standard level of quality that you have to meet to transport data. You want to make sure your data is safely transported, that someone can't get into your connection and steal information. You want to make sure that you don't lose information. You want to make sure that if something didn't go through, you're going to get a report back that lets you know. So everything is shared in a safe way. But HL7 is what allows the PACS and the HIS and the RIS to all communicate with each other. So this is just talking about primary HL7 standards. This is a little bit more detailed, but this kind of gives you an idea. This is what the actual standards are for HL7. So you have to have a version 2.0 or greater messaging system. Version 3 messaging system is standard for health and medical transactions. Clinical document architecture is talking about an exchange model between clinical documents. Continuity of care document is a U.S. specification for the exchange of medical summaries based on the CDA. Structured product labeling, so SPL, is the published information that accompanies medicine based on HL7 version 3. And then the other one I mentioned here is Clinical Concept Object Work Group, CCAW. That's an interoperability specification for the visual integration of user applications. So these things are what, when we hear HL7 communication, or I'm sorry, HL7 interface, but these are some of the actual details of how that, what that interface actually means, or that HL7 connection means. And I did want to bring up something called vendor neutral archive at this point. So a VNA is basically when you archive something. So when you store something in your, after your PACS, it's going to go into storage. And vendor neutral means that it is stored in such a way that it is neutral. So it can be transferred from one PACS system to the next. That way, if you store all your data and you decide next year you're going to change PACS companies, if we hadn't used a vendor neutral archive, we may lose our data, or we may not be able to get our data back. And so this allows us to be able to get our data back. So it sets a standard that says, all data that's stored has to be stored in this format. That way we can always get it back and use it as we need to. So a radiology information system is, it's going to be referred to as a RIS, and a RIS is an HL7 networked software for managing medical imaging and associated data. So that HL7 part means that if it communicates with any other parts of the process, it has to be through an HL7 interface. Some of the more important tasks that you're going to think of with a RIS system is, registration and scheduling, result tracking, reporting, patient tracking, interface with the modality via the work list, tracking of radiology imaging orders, billing information. The doctor's order and the billing information are always really important. That's part of the job of the RIS. The RIS is used in conjunction with the PACS, and like we just talked about, a VNA, vendor neutral archive, to manage the archived images, record keeping, and billing. That opposed to a hospital information system, or a HIS. Hospital information system provides a common source of information about a patient's health history. The system is a secure data system that's going to basically keep anything related to the hospital side, whereas the RIS is related to the radiology side. And it enhances the ability of the healthcare professionals to coordinate care, because it's providing patients' health information history, visit history, results, things like that, at the time that they need them. And again, a HIS is going to communicate with other products via an HL7 interface. And the last slide I have here um, is talking about the Mirth engine. Um, and the reason I put this up is we use a Mirth engine for our product. And it's an interface that enables bidirectional sending of HL7 images between systems and applications over multiple transports. And it was developed under Mozilla public license. I wrote that here. I don't know that it's really that important. Um, so Mirth is using channel architecture to connect the health information technology systems and allows messages to be filtered, transformed, and routed based under defined rules. The channels are consisting of connectors, and there's multiple different kinds of connections that you can perform on this. So in our case, um, if we want to do an interface with a EMR, so an EMR is an electronic medical record. Um, every nursing home, I say every, but a lot of nursing homes, but certainly every hospital is going to have its own EMR system. And so if we want to get our report that we generated back into basically their medical records, we have to send it into their EMR. And to do that, we have to have an interface with them with their EMR. So if we wanted to do that, one way we can do that is perform the interface with Radius to each of our individual customers. It's possible to do that. It's going to cost about $5,000 for each interface, and it's going to take time and manpower to do that, as well as communication with Radius to get it done. So what we did is we made a Mirth engine, and so right now information is going to go from the modality that's taken. It's going to be sent through the gateway to Radius. Once it gets to Radius, we have a VPN that's going between Radius and our Mirth engine. So when the information gets to the Mirth engine, now it can pass forward onto our individual clients. So now when we want to perform an interface with an EMR, we're going to be able to do the interfaces through these channels on the Mirth engine. So we are basically using our Mirth engine kind of like the edge gateway that Radius uses, to allow them to not have to have a VPN at each different facility. Well, we're doing that with our customers, so we have to make a safe connection between the Mirth engine and the individual EMRs, but now we don't have to make a new connection every time to Radius. We just need one connection. So that's kind of the idea behind using the Mirth engine, and making things a lot easier for us. One thing that I think is important that I didn't talk about as of yet is, so where do we actually store that radiology report? In the past, what they would do is they would get the radiology report converted to a PDF and then actually store it in the PAC system as a DICOM file. And that's what Metametrix is still doing to this day. It's a very inefficient way to do it, and it also creates conflict problems with different PAC systems. So, general speaking terms, they don't like you to do that anymore. So they prefer you not putting the actual report in as a DICOM image into the PAC system. So what will happen at this point is that report is, like I just kind of talked about, is going to get inserted into the EMR, so the electronic medical record system, via an interface. Just to keep in mind, an interface for us right now for individual clients is going to cost anywhere from about $1,000 to $3,000. That's a cost on our side. Then there's oftentimes a cost to our end customer that's charged by the EMR system itself, which may be another $3,000 to $5,000. There are some companies like GE or AGFA or something like that will cost $30,000 or $40,000 to the customer. So when you put an interface in, It does definitely make a customer a lot more excuse me, a lot more sticky of a customer. They're not going to be near as likely to want to switch to another provider, because then they're going to have to redo their interface. And on top of that, sometimes these interfaces can take a little bit of time to get set up. Not that they're so time consuming to set up, but it's a lot of back and forth between different IT people, between the hospital and our IT guys and Radius and things like that, and so it can get kind of prolonged and drawn out. All right, thank you.